take to more cloud-based solutions. So one approach is to host the data in the cloud. So there's currently a larger community around Pangeo, which already took a subset of CMF6 and hosted it on Google. We are also currently working together with Amazon, together with our American colleagues, to have an Amazon cloud prototype, not only hosting the data, but also core ESGF services. And we are also working on this at the institutional level. So for institutional pilots at the different sites where we want to get, we want to essentially learn how to move forward. And the specific here is, so what we need to do is to provide essentially an analytics optimized data store, and this needs to use cloud native data storage formats like SAR. So we use SAR to store our netCDF data. So most of our data is netCDF format. So this is essentially the route to host data on the cloud. The funding models behind this are currently complete. And the last point is, besides hosting data in the cloud, we are currently also going forward to host individual infrastructure components in the cloud. So for example, a centralized search index, the core components of the security infrastructure, and also load balancing components. Okay, I think that's it from my side. Thank you.
Okay, perfect, Stefan, right on time. Thank you very much. Lots of good information, lots of interesting directions. I would propose that we, if you have questions, I encourage you to post them, but we'll try to deal with them at the very end so that we can get through everybody's presentation. So now I'd like to invite Martin Palkovic from ECMWF to describe the work that ECMWF and UMETSAT are doing to federate some of their capabilities and also to create capabilities for other national meteorological services. Martin comes from a long background in this area, deep technical background, and is currently the director of computing for ECMWF. So over to you, Martin.
Well, thanks, Mark, for the introduction. I hope everybody can hear me.
Yeah, we hear you well. So
okay, perfect. So good. So I will wait till the presentation is started.
Far right, Billy. There we go.
Yeah. Okay, as said by Mark, this is a joint work between ECMWF and EUMETSAT to federate our capabilities and also just additional capabilities of eventually our member states. So this is the European Weather Cloud. It's really cloud computing based infrastructure focused on the needs of meteorological community. Next slide, please. Just a short intro to ECMWF for the people that don't know the center. So we are an intergovernmental organization established in 1975, 34 states, 22 member states, and 12 cooperating states. We have headquarters in Reading, UK, and currently we are building our new data center in Bologna, Italy. And what is unique is that we are a combination of research institute and 24/7 operational center, because of course we are delivering to our member states medium range, global medium range weather forecast. So twice the duration of operational weather forecast, and we assimilate 60 to 80 million observations per day. Our archive is really petabytes of observation and forecast data. So currently the primary is 350 petabytes, and the climatological data is 250 out of that. So IT infrastructure, HPC facility is globally one of the largest weather sites. So recently we signed a contract for next system that will be composed of four Atos Bulls Aquana XH2000 systems. or complexes, and will deliver in total close to 40 petaflops. Please, next slide. So why we need the cloud? I mean, I was speaking a lot about large volumes of data we have, either from observations or from simulation. I was speaking about 40 years history in HPC or 45 years history in HPC and large HPC facility. But we see that by going to finer and finer resolution, just the produced and disseminated amount of data is really rapidly growing. So of course, because moving of data is expensive, so we are looking move computation close to the data and not the data to the computation. Next click. And we see that the methodological community also, as said in the previous presentation, is really looking at that, just doing things in the cloud, just having the cloud infrastructures, and so on and so on. Next slide, please. So we started discussion with EUMETSAT basically around 2018, and we converged that we would like to really create cloud computing-based infrastructure focused on the needs of methodological community and building on the expertise in methodological data owned by the two organizations. Why not commercial cloud? I mean, commercial cloud, yes, we are looking at that as well, but because we would like to put some crucial functions there, and also just the proximity of data, we are looking at our in-house solution, cloud solution, and we would like to enable any entry of the EMI to join the infrastructure. That was the original goal. So the work is built on the experience gained by the two organizations in cloud computing, and the proposal for our councils that was approved was to do the 2-year pilot and then to evaluate if we go with that to the operation and how we go to the operation. And the pilot started beginning of 2019. Next slide, please. So we are at the end of 2020, and what is happening with the pilot? So the pilot phase has been extended by a year. So basically next year will be the 3rd year of the pilot. We have the pilot infrastructure in place on both sides. We have joined landing page and support portal, and we continue to develop use cases with first success stories. And actually, it was when Croatian Med Service was hit by the earthquake, they were successfully using our cloud, our European weather cloud, to do their forecast. So for some of their basically their needs. So even we were in the pilot, we already helped in this situation. More technical developments are still ongoing, data access and notification and so on. Next slide, please. So what is the infrastructure at ECNWF? So we deployed Morpheus as cloud management platform and OpenStack cluster, and currently is upgraded to last version. We see also a lot of machine learning workloads. So we added GPUs for machine learning after user feedback. And as said, this is really important that we have fast access to our Mars archive data. So basically our forecast and our data from the past. So there are some specs on the slides you can look at. Next slide, please. I mean, this is the infrastructure, but what is very important is the use cases. And use application cases are our way to evaluate and learn how to operate a cloud platform and how it can make a difference to our users. So we have more than 28 use application cases actively managed. We have joined working group with EUMETSAT, and 15 of those have started to use the cloud. I was mentioning also Croatian Med Service, where we helped machine learning workload, but a lot of other workload as well. And we have regular just workshops where we are presenting the progress we are discussing with the methodological community, and that's really very good. Next slide, please. So what about the federation? So when you look at the federation, so we really constructed this as loose coupling on cloud management level with Morpheus, so that both sides can evolve independently. users can create and access resources on the cloud and on other clouds, so either ECNWF or EUMETSAT, and we ensure common interfaces and naming convention between sites. So users can easily switch between the systems, and also the cloud allows virtual machine interoperability. We have also access to common object storage space from both E&E partners, so ECNWF and EUMETSAT. We are in first discussion with member states how to integrate their data, because they have also a lot of their local data, and how the European Weather Cloud could be integrated in their IT offering. But just know this is still a pilot, so we hope to go in operation then end of next year. And currently, basically, we started the procurement, so RFI and ITT for this. Next slide. What are the potential types of federation we are looking at? It's association federations, where member and cooperating states of E&E will have allocations via their memberships on their respective cloud infrastructures. Then data federation. So data federation integrates data from many different sources with the ultimate aim to make data sources from E&E and their member states to appear seamless. So that's really just we can access the different data in the federation, and also the cloud federation, where basically is federating the resources via the cloud federation. Next slide, please. I would like to say that European Weather Cloud, as cloud computing-based infrastructure focused on the needs of meteorological community, is not living on its own. I mean, we heard already Copernicus, CDS, there is also Copernicus ADS, so Climate Data Store and Data Store. Also DIASys and DIAS Wikio, that's another cloud platform, and also European projects. But what I would like to highlight maybe is also Destination Earth, because Destination Earth, as you know, or some of you might know, should bring the digital and the Green Deal together, and it will have also strong cloud component. So we need to understand how this is working together and interfacing together. Okay, thank you. That's it for me.
Okay, thank you, Martin. That was an excellent presentation. I really appreciate it. We already have some good questions from somebody named Tiziana Ferrari, but I will defer those to the end of our presentations. Next, we have a talk from Peter Thijs. I apologize if I'm messing up the Dutch name. Peter is the project manager for, I'll just get this, project engineer for MARES, which is a marine data management company in the Netherlands. He studied as an aeronautics engineer and then realized it's much more interesting in the sea. So I look forward to Peter's presentation. So Ville, if you could bring his slides up.
Yes.
Excellent. So over to you, Peter.
Nice introduction, Mark.
Thank you.
Yeah, I'm Peter Thijs, as you pronounce it in Dutch, but it's hard. Representing MARES, the SME in the Netherlands, but I'm actually representing the CDataNet community, and CDataNet is now an AISBL organization that is also now a member of the EGI. So what I'm going to present to you are the developments to develop harmonized marine data access from the cloud, and I'll fly you through the developments that are relevant in the marine community. Next slide, please. So yeah, we all see it on the news. Oceans and sea are important for climate, and also to see what the effects of the climate for energy, for food, tourism, shipping, health, etc. Next slide, please. And there are many users. I'm not going to mention them all, but you will see it pass by. It's important for coastal zone management. It's important for agreements between countries and marine conventions, EU strategies in the Green Deal, for the blue economy, for fishing, etc. So next slide, please. And there's a whole lot of sensors and materials out there to measure, from vessels, from remote sensing to vessels, to buoys, gliders. There's a lot floating under the surface that you don't see, to moored stations. Next slide, please. And there's a big amount of money invested to collect these data of the seas. An estimate is 1.4 billion euro, 1 million on in situ, so in the ocean, in the seas observation, and about 400 million from satellites per year. And what is important there is that because there are so many sources, that there's professional data management, and for standardization, quality control, and long-term archiving. Next slide, please. So that is where CDataNet came in. CDataNet is a pan-European infrastructure cooperation between the National Oceanographic Data Centers, NODCs, from 34 countries. And they've been working in a series of projects, almost forming a program to work on exactly that to facilitate the harmonized access to data and work on the standards together. Next slide, please. For that, of course, we have a portal, like every initiative has, to present the standards, tools, services, the data, access to the data, the access to the data products. And it can be used for both the data centers that are in the group and new data centers that want to publish their data, and for users of the data. Next slide, please. As I said, what is important is, because the domain is so varied and every data that is collected has more or less an initial use in the country often, and then has national standards, but also a reuse. And that is where CDataNet comes in. When you share data for the second time, then you cannot use the national standards. So we have developed a set of overarching standards with metadata based on the ISO 19115, 19939 profile, but expanded with a lot of vocabularies, controlled vocabularies to describe the actual parameters in a data set, the instrument that it was used for, the organizations that are involved, etc., etc. And then there are also some standard data exchange formats. The most important ones are an ASCII format called ODV and NetCDF CF that is also used in other communities. But then our NetCDF CF is also again supported by controlled vocabularies from CDataNet. Next slide, please. And to demonstrate and allow also the use of these harmonized data sets then that are exchanged, we've developed a set of tools. Most important, well, not only tools to create the metadata and to create data conversion from the national standards to the international ones, but also to analyze the data. There's ODV software, and to do data interpolation to create an actual product, for example, a climatology of the water temperature over the last 30 years. And there's DIVA software that supports that. And of course, there's a lot of capacity building to train people in the standards and how to make use of it. And there's a common data policy, which is also very, very important. Next slide, please. As part of these vocabularies, it's also important that we do not only describe the data set, but actually also describe where it comes from. So it's related to fairness. That is a big thing at the moment. To describe the provenance, where does it come from? Which organization is involved? And therefore we have, for example, the EDMO catalog. Which cruise was the data collected in? A research cruise. Therefore we have the CSR. Which research project does it come from? So that is also additional, more or less, vocabularies. Which observation program does it come from? Next slide, please. So when you find a data set, you can really search on all these facets. So what we have is at the bottom left here, we have the European data sources. In total, about 750 originators. We have 110. If you click once more, please. Then you will see some
Ville?
Yeah, Philip. Yeah, thanks. We have about 110 data centers connected. And what we do is because it's so distributed, we had to build a data cache to make data easier accessible. So we created a data cache with about 90% of the data, which is unrestricted, that is directly accessible from the cloud. And you can search on the metadata via the CDataNet portal, via a dedicated interface. And then you can shop and select exactly the set that you want. We also have machine services nowadays that work more or less the same, but then you can query against it, for example, from a Jupyter notebook. Next slide, please. The cloud itself, for storage, in the CData Cloud project, which is ongoing, almost finished, we cooperate with 5 EU data centers. We use the B2 components, B2 Save, B2 Handle, and B2 Stage. B2 Save for the storage, B2 Handle for the assigning of PIDs, and B2 Stage for the whole communication to ingest it into the cloud and for the order and delivery of the data. And in the cloud, we do additional quality control during the ingestion and also duplicate checking, for example. Next slide, please. So yeah, this is what you then get, 2.5 million data sets. So it's not in our domain, in CData at least, it's not about the size of the files that are usually not so big, but it's about the amount of data sets for the observations. Next slide, please. We have a lot of corporations from internally in the marine domain, CMEMS, EMODnet. I'll tell you a little bit more about that, but also wider to, for example, GEOS, the GEOS community, where we share aggregations of the data that we have. In every corporation, it's important that CDataNet provides the essential data management. So more or less the base for sharing the data. Next slide, please. One of the nice cooperations now that's ongoing is to overcome one of the challenges that we have is, as I said, we have 110 data centers connected. Not so easy to get the data replicated. And we have been investigated together with Gegeli. I saw that and his team. I saw that he was on the call to use the One Data software actually to publish the data and make it accessible to a cloud instead of a component that we have now, which is really dedicated replication manager. And it looks good. And another thing is that we found that it's very hard to provide fast access to this large set of data files. So we're also looking to load that data and the measurements, all the measurements themselves into a NoSQL Cassandra database and then visualize them with high performance. So that's a nice pilot. Next slide, please. And then in the end, you can get really on the fly, direct view of the data. And that is a very nice result. Next slide, please. If you then look to the marine domain, it's not only CDataNet, there's also EMODnet that provides data, many data products of all kinds of domains. And you have the CMEMS for the remote sensing and modeling data that work together. They are more or less bridging from where you have at the bottom the observations to at the top, you have the users, industry, government, research. Next slide, please. So these communities, these infrastructures that I mentioned with EMODnet, CMEMS, and the others, we try to bring them together in what we call the Blue Cloud. The Blue Cloud is a project now, just started 1 year ago, to provide access to the various data streams that we have, to this multidisciplinary data, and then allow users to not download first and then work locally, but work directly in the cloud with the data coming from various resources, and then have computing facilities there. So it's a kind of overarching cloud infrastructure. And it's we see it as a thematic EOSC component. It's in a pilot form to shape the path. Next slide, please. And in there, we have on the left all the infrastructures involved from observation. Well, you can see them. We even have marine biology, marine genomics in ENA, ICOS for carbon, etc. And on the right, we have the corporations to facilitate the cloud, the D4Science infrastructure, the cloud processing, cloud storage, with the EU DAC together. Next slide, please. The overall concept is to come from discovery and access, harmonized discovery and access via applying standards over all these infrastructures, and then facilitating research in the VRE. Next slide, please. And then what is important apart from that we try to create these virtual labs via a series of demonstrators, but also bring in a roadmap to 2030, for this pave way how we can create a blue EOSC. Next slide. Yeah, this consultation, I'll skip that one for now. Next slide, please. And further challenges are that we want with the marine community to work, for example, related to the Green Deal, in a digital twin of the ocean that is hot now. Work towards the EOSC future. As I said, the marine component in EOSC is very important. For the fairness and especially the provenance, it's important that we have more direct access to our sensors via, for example, the Internet of Things and sensor standards. Artificial intelligence and machine learning is especially important since we have these data caches now that we can apply additional QA and QC in the cloud. And yeah, the first pilots are in the way, not only for the VRE, but also to apply HPC. I already described the DIVA component to create these big climatologies of many files at the same time. That's very processor consuming. And the first developments in a project, for example, called Phidias, are underway to experiment with that. Next slide, please. Thank you very much. That's it for now. If you have questions, I will see them on the chat. And you can look to our developments both on this domain and an email if you want to contact me directly. Thank you.
Well, thank you very much, Peter. That was a great exploration of not only the disciplinary area, but also how you're trying to solve the problems and look at federation as a possible solution. So we've had 3 presentations from, if you'll recall, Tiziana's pie chart showing the different areas of disciplinary activities as part of EGI. These 3 are all from one slice that is kind of the climate Earth observation area, roughly a 17–18% slice. So we have another 16–17–18% slice in the life sciences, and I'm pleased to invite Rishi Nag from the Global Alliance for Genomics and Health to share some perspectives in genomics, a different area, but quite a relevant perspective. So he is the technical program manager for GA4GH and helps manage collaborative projects for that alliance. So Rishi, if you would pick up the baton and carry on. Thank you.
Thanks for the introduction there, Mark. Yeah, if you could have the slides up, please. That'd be great. Cool, thanks. So I'm going to just talk about what we do in GA4GH. We are a developmental of standards organization. So this is kind of if you want to go into the next slide, please. We're going to do a bit of introduction to a bit of background on the genomics space and how it's changing due to healthcare. Then I'll talk a bit about GA4GH itself and this GA4GH Connect structure we've got, and then an overview of kind of the standards we've worked on and process we have in place. So next slide, please. So traditionally, the genomic data pipeline starts off with what we call sequencing. So we have 2 kind of objects here. So sequencing is where you take a biological sample, put it into a machine, and it turns out if you've got DNA, your A, T, C, G, and letters that you sort of know and love that make up our genomic process. So basically, we start off with a really well-built reference genome. So we sequence this very thoroughly and put it together very carefully with various tools. And this becomes what we call the reference genome, and there's 1 for each species typically. Then an individual comes along, and that is sequenced much more quickly and cheaply. and we get sequences of letters that are typically, say, 100. The new technologies are coming along, so these are 100 letters long. And what we can do is use the fact that 99.999% of our genomes are exactly the same. So we take these reads, these sequences of letters, and say, try and find where they align to on the reference genome. So the two kind of data formats we're dealing with are, in the bottom right corner of this slide, the reads, which are, pile up. And then the other area of interest is once we've aligned reads to where they match the reference genome, where are they different from the reference genome? And we call these variants. So these account for the biological, help account for the biological differences between individuals. These little letter might be a T in one individual and a C in another individual. And this can have a different effect. So next slide, please. So, some basic genomic data standards we've had are these read formats, which we call BAM and CRAM, are the sort of two in vogue ones for reads, and variant formats. And this standard here is called the VCF. And then a concept to have here is the difference between two individuals, where we call them alleles. So this space has these have been developed in the academic space. And for instance, there was a 1,000 genomes project a few years ago where 1,000 of these genomes, individuals are sequenced very well, put together, and made available for academic research purposes and were publicly available. Next slide, please. However, we are in a changing world, and what's happening now is that we're getting a much greater volume of these genomic sequences coming into play, but they're coming from a different place. We're no longer being able to get 1,000 individuals to say, yes, we'll donate our genomes for public research. What's happening is individual healthcare systems are funding these genomes sequencing, and this then means that various other criteria come into play, in particular their sort of public availability. We do this for rare diseases, for instance, cancer, infectious diseases. So, given COVID's kind of the in vogue thing, we know that there's a load of people who don't experience symptoms of COVID, and we know that the people who end up being hospitalized, are there variants that are related to the people who end up in one place and the people who show no symptoms? So next slide, please. And these and the scale of this, I mentioned the 1,000 Genomes Project being a big thing a while ago, but now we're looking at millions of people across the world being sequenced. And an important criteria here is that the data may not be able to leave these certain jurisdictional areas. So, for instance, if you're looking at Australia, anybody sequenced in that space in a particular state, or Canada as well, the data cannot leave that state once they've been sequenced. And similarly in England, Genomics England sequences, well, it says 100,000, now they're aiming for 1 million, but the data cannot leave a building that has been specified as the secure location for that building, for that data. Next slide, please. So we're just saying here that rare disease are another use case, as well as cancer. Let's just go on to the next slide. And the solution here is to, as we've mentioned, the federation word. Yes, the solution is kind of a system that attaches these data centers together, but that acknowledges the data cannot leave the data center. It might be jurisdictional, it might just be, and as well as the sort of jurisdictional limitations, there's limitations on the physical size of the data set. It used to be you could download all the 1,000 genomes data set, run your analysis, and that's fine. But when you're looking at 60 million patient genomes that we're looking at across the world, that's just not feasible. You then have to have consent attached to patients, because to make these variants useful, you have to sort of know what makes this patient special. So is there like we mentioned, is there how they respond to sort of COVID infections? Is that something that's a piece of personal information? Is it related to where they live, or sort of how their family and stuff like that? So there is challenges here, but the data sharing benefits in the genomic space means that there's all sorts of benefits here. So in particular, we mentioned rare diseases. So these are people that a genetic variant that might cause a deleterious effect, have a negative effect in patients, in 1 in a million patients. And you can make a stronger diagnosis if you can match the patient's symptoms and the variants together with something else, but you need to be able to search in databases across the world. And also there's a strong space, a lot of experience has been developed in the academic space. So how do we translate that to the clinical space and help, first of all, the clinicians provide data, these health funded genomes provide data to help benefit clinical treatment developments and diagnosis tools, and then to sort of complete the circle, then the clinician will be able to sort of feed in a sample and then get a sort of more informed clinical decision. So next slide, please. So part of this is, so I mentioned we've got to move the analysis to the data, and that's the biggest sort of cloud-related item here. And I've talked a bit about the other points here. So let's go to the next slide, please. So I'm then going to talk about, so that's kind of as our motivation for doing things and getting together with standards. We need standards if we're going to be able to build this federated system of sharing data and being able to make data accessible rather than sharing. And GFGH has been around since sort of 2013, 2012, 2013, but in 2017, there was a revamp in what we call GFGH Connect. We identified technical areas of cooperation, so then we call these work streams. We then put them together with, got together with big data holders, such as, and these can be places like Genomics England. There were slides previously mentioning ENA and Elixir. They're very important collaborators. There can be disease-based space. So these are people who hold data sets. GFGH doesn't hold data itself. And we said, what are your areas of cooperation here? What are you both interested in? So for instance, if you do have a rare disease patient, I mentioned a doctor might have a clinician might have a patient and they picked up, these variants might be interesting and they might have certain symptoms, but how can someone in England find a matching patient that might be in Australia or South Africa? So these people, so the discovery work stream here is kind of sort of to do with mechanisms for doing that. And then the cloud is about sending analyses to the data and frameworks to support that. We then have to put this together with security and regulatory and ethics frameworks and policy frameworks to make this come together. So next slide, please. And here's an overview of some of the projects we've got working together. I know that some of the previous presentations were part of the Elixir and ENA work as well. But it's trying to be a global organization, so with organizations across the globe in different areas. As well as these driver projects, we have many other contributors, including Illumina, who make most of the sequencing machines, and AWS and Azure and Google Data Cloud, cloud platform participation. Next slide, please. And yeah, we're trying to do this to help meet fair data principles. Next slide, please. So if we go back to our original kind of idea of here's the academic-based pipeline of we have a reference genome and we just sequence and we get reads and variants. We're now building up, we're now attaching more data to these ideas. So we have patient data, which is now attached with consent. So the patient data might be the background, pedigree is about their families, obviously reference genomes are inherited between their generations, and then the symptoms, we call these phenotypes, and these may not just be symptoms like characteristics like height or hair color. They may actually be how does someone respond to a drug. So it may be that variants, if someone has a variant, they may or may not respond to a particular treatment. So you want to be able to capture that. But these are now more, you're adding privacy concerns to how things are progressing. Next slide, please. So this is kind of the ecosystem that we're sort of looking to build, or part of the framework here. You're having data going into data sets that might have jurisdictional restrictions. One of the things that might be relevant to point out here, as mentioned, was that sort of here, we're looking at all the information on a patient, on a single patient, including their sequencing information, their clinical information, phenotypic information, will sit in one database, whereas I think Mark mentioned that this might be more distributed in the kind of your usual use cases. But where the researcher is then looking at sending their analyses to run through the cloud, run on cloud platforms attached to those data centers, and getting just the results back and not having access to the data directly. Next slide, please. So this kind of talks about our standards so far. We've had a plenary, and there's a kind of a walk through this diagram on a video on that plenary. I've put the details there. So I guess some key points here are, I guess we start with the data donor. They are attaching consent to data sets. Part of this is later on is the data custodian, puts this data into a database. And then we have a raft of data sets which are about retrieving the data from that database. The consent needs to be matched up to what the researcher is allowed to see. So we have a couple of other, as well as the consent codes, we have things like GFGH passports and ontologies, a data use ontology to help map. The passport will describe what the data researcher is allowed to access, and the data donor, and it might, so the data donor, the consent might be framed as something like, I agree to let my data be seen by pancreatic cancer researchers who are working in the academic field, and the GFGH passport will kind of sort of have that criteria attached to that passport. So when they're accessing the data set, it's done computationally. Next slide, please. So one of the things I mentioned was like trying to get into find data across data sets. So finding variants is a quick thing of interest. So there's a process to go through, a regulatory process to go through to access data because of privacy concerns. A beacon, for instance, is a simple thing that says, do you have this variant? This, like I talked about, a change in letter at a particular position, and it can reply yes or no. And if there's a yes, then they know, okay, let's go through the process to sort of get approved for access. So next slide, please. And finally, I'll just talk about this this slide, which is about the suite of cloud workstream APIs. Obviously, they're available to use outside the genomic space, but one of the criteria is not just data. The workflows need to be managed so that clinicians, a hospital can say to 10 different clinicians, here's a precisely defined workflow, use this. It's a sort of checksum special, uniquely identifiable thing. And oops, that's my time up. So yeah, that's our cloud workstream in action there. Hi, Mark.
Are you done, Rishi?
Can I just spend a minute just on this slide?
One more minute.
Okay, just on the previous slide, if you want to go back to that. So if you go back to the previous slide, then yeah, just talking about, these are the suite of tools to allow an execution to take. So the tool registry service is important for clinicians use to have a precisely defined workflow. Often, say for instance, in health services, they need to have something recorded for 20 years so they can replicate how things went. The workflow execution service provides a way for endpoints to run workflows defined in different languages. And finally, of interest is the data repository service. So this is a way of now describing things, because you don't know where you're accessing the data from, you'll need to have a unique identifier in a federated system to say, okay, here's a way of resolving a particular identifier to your endpoint dataset. All right, thank you very much. Sorry about going slightly over that.
Not a problem at all. Thank you very much, Rishi. So just a quick comment, some great commonality amongst the four presentations. We see a lot of the same functional pieces, but put together in different ways. And as I'd mentioned to Rishi and we'll mention to everyone, an interesting variation between the climate world and the genomics world is rows versus columns. So Rishi's got a bunch of rows spread out all over the world, and our other presenters have columns in lots of different places. So columns of data, fields of data. So each has got the same problem of trying to put the pieces together in a safe and efficient way from both a data standpoint and a computational standpoint. So we're trying to solve those problems, and federation is is kind of the magic sauce that we're trying to use to solve these problems. So as I'd mentioned before, we do have quite a number of questions already from again this very interesting person named Tiziana Ferrari. And I'll ask each of her questions in the context of everybody. So I'm hoping everyone will speak a little bit about their respective answers to these. So the first question is the use of commercial clouds. This appeared in everyone's presentation, and I'm wondering if each of the four presenters could walk through and talk about the role that commercial clouds are or might play in their specific architectures. So we'll start with our first presenter, who was Stefan.
So the role of commercial clouds in our context is quite different in the international context of the US and in Europe. So US is certainly pushing towards using commercial cloud services, and they get some funds to try things in this context. In the European context, we are more interested currently in the cloud technology and using and deploying services at institutional cloud level. So we have currently no clear route to using commercial clouds.
Okay, thank you, Stefan. I'm going to jump in on each of you. I apologize, just to maintain our time. Martin.
Yeah, so as I was highlighting, the meteorological community is looking at public or commercial clouds. We are looking as well, just try to do some bits and pieces and try to look how it's working. Some Met services are even further, like the UK Met Office and so on. So with respect to cloud component, I think it's an important option for elasticity, because we can build in-house cloud, but we cannot scale it in such nicely like the public and commercial clouds can do. Maybe can I answer the other questions, or should I do it in the chat? Because there are some.
Well, we'll go through the questions, so we will get there.
Okay. So I will leave it for later. Okay.
Okay, so Peter, I know you'd answered part of the question about the use of clouds in reference to payment scheme. Any additional comments you'd like to make?
Well, I can be short. We are not in CDataNet and also not in Blue Cloud. We're not looking into the commercial cloud providers. But as Martin, I think, mentioned as well, we do expect that when a certain service is very successful and should be kept operational 24/7, then it should be, we expect that it should be running there, but no, not directly in the project, no.
Okay, thank you. And Rishi, you did mention that at the very end of your presentation. Any additional thoughts?
Yeah, no, we have very much, I guess, we want our standards to be used as widely as possible, and and that means commercial cloud participation is going to be important to us. And some institutions actually, like I mentioned, Genomics England has its setup in a self-contained building, but on the flip side, you have something like Australian Genomics, where their institutional setup is closely related to Amazon Web Services, for instance. So having the standards on those frameworks benefits the commercial cloud providers as well.
Okay, perfect. So I'd like to move on to the next question, and it's actually quite general, which Tiziana posed to Martin, but what are the gains expected from, and I'll generalize your respective approaches to federated solutions. So again, I'll start with Stefan, where he sees how federation solves problems for his community.
So the key aspect is we have a very diverse end user community, and the only way to be able to provide a consistent set of services is that different institutions harmonize their services and integrate them into a consistent federation. So this federation concept is in the core of our approach to fulfill our mission to distribute the data coming from the modeling centers to the wide diversity of our users.
So you see federation as driving a bit more standardization.
Yes.
Perfect. Okay, and Martin?
Yeah, I mean, yeah, I agree. I think for the question, particularly the ECNWF and EU MedSat, I mean, it's the data from the same domain, but we have the simulation data or results of the simulation, and they have the satellite. So it's natural to have the seamless access to this type. The federation of resources, it's extra bonus, but I said we can do it also with the elasticity. So, and currently we are working on use cases for them, for us, but also looking at this federated use case where we can show the benefits. So it's really just mainly accessing seamlessly the data, but also having access to the resources. And those are the two biggest sources, the EU MedSat and ECNWF.
So it's accessing data, accessing the computational resources, if you will. Okay, Peter?
Yeah, same here again. Accessing, you seen in my presentation that the landscape is very wide already in CDataNet, and then also if we add up the resource, the data infrastructures from Wakio and all the others. Yeah, we need to, if we want to provide seamless access, we need to work through federation applying the same standards. Yeah, Inspire is not enough, so we have to go way beyond that.
Okay, interesting. Yep. And lastly, Rishi, I think you have an obvious answer, but let's get your thoughts.
Yeah. So my thought of the obvious answer is basically I mentioned that variants are the kind of key to helping making clinical decisions and how they respond to things, but it's a very noisy data set given the size of the genome and things. So having 10 million genomes over which to sort of get confidence, and this is a variant of significance to a particular medical diagnosis or treatment, is much better than having 1,000.
Okay, simple, increasing your cohorts. Perfect. So I have a question from Yuri Demchenko, and hello, Yuri. So he's asking about applied data sharing. Have you applied data sharing policies linked to the data? Now, I guess I would couch this the way he asked the question. It's I hear echoes of the International Data Spaces architecture, and we're here in a very fair open data environment. I'm wondering if, I know that GA4GH has the DUO, the data use ontology. Perhaps Rishi, you could talk about data use ontology a bit more, and the other three folks could talk about any usage models or data usage limitations that they're aware of, say, zooming in down on specific pieces of land or property, which might be seen as a privacy issue. But Rishi, if you could.
Yep. So our data use ontology, I think this is kind of one of the most exciting things is this process matches at the moment, clinicians can write something down saying, oh, this patient consents to use their data for these purposes, but to map things onto the global scale, you just need to provide, very precise things so things can work computationally. And the GEO is that precise definition of things that can be used to make what we call consent forms that get ticked off as relevant in the clinicians, gets tagged in the data set, and that gets, when someone queries a data set, I mentioned the beacon, for instance, someone can get a yes/no answer to, is the variant in the data set? But to get more information about the variant and the patient's criteria, they will need to show that they can match that ontology's requirements. So it's not just the ontology itself, it's turning into the forms, and then we need to reach out to partners in the healthcare space to sort of get that as part of their process. Obviously, that's a very, it needs hospitals to kind of change their processes.
Okay, any thoughts from our Earth observation world?
Yeah, let me maybe start. Yeah, let me maybe start, because the question was about, particularly about the European Weather Cloud, applied data sharing policy linked to data. Yeah, we are working on it. Definitely will be there with the operations, and we are learning from the past and from what we were doing in the past. I mean, climate data store was mentioned several times here. So there it's more as a data connector. So, but some containers as well. So we have to see. But basically, definitely yes. But still, work is ongoing there.
Stefan, Peter?
Not much to say. So it's mostly open data for in the climate world. So for this we have generic data sharing recommendations, like how to cite the data and so on, and we can attach policies to specific data sets which are then enforced in the infrastructure. But that's essentially it.
With us, it's we have 90% is open and unrestricted data, where you just have to. It's like CC BY 4.0. With the right reference, you may use it, and about 10% has restrictions, and that is set in the metadata, saying that it is by negotiation, and that usually has to do with either embargo data for research for the first 2 years, or commercial value, or very sensitive value when it comes to pollution, for example, in areas, and that the data center first wants to know who is using it for what.
So Peter, on that point, do you have a shall we say, an automated or formalized process for handling those kinds of restrictions, or is that kind of a case-by-case situation?
Well, it's in that sense, when via a service or via the user interface, a user orders the data, where a part of that data that he orders is by negotiation, the trigger will be sent automatically to the data center. Somebody has to view it and then can push a button release, and then it's released automatically again via the cloud to the user. Mm-hmm. But the restricted data is not kept centrally on the cloud. It's kept at the data center that is connected, one of the 110. And once they press the button, release it for this user, then it's released via the cloud. So it's replicated from the center to the cloud to the user.
So it's one by one, as opposed to some sort
one
of
by one. Yes.
Exactly. And Martin, coming back to you, do you in your world of weather data, do you have specific data sets that have this same kind of commercial sensitivity? Maybe they are local weather forecasts produced for certain users or farmers or national services that are not that others don't want to share so much.
Definitely. I mean, just know that our data, we are also just distributing commercially to big customers. But I mean, our council is willing to go more and more to open data, and we will see how far we will go, because of course open data means that just everybody has access, but then the revenue that we have from the big players that use our data basically will drop down, or will go to zero when it's open. So we do it in the really slow way. But of course, when we are engaging with some public funding agencies and public bodies like Copernicus, data is open. Also, we tackled a little bit on the destination Earth and so on and so on. So basically, where public money is there to produce the data, definitely the data will be open. But just a lot of data is produced that we are producing is produced by the financing of our member states. So they have, of course, access to the data, but then we are restricting it because of also commercial sensitivity. But we are going more and more to open data. We will see how far we go there.
So it is now half past the hour, 12:30 Central European time, which is strictly speaking the end of our session. But I know many of you want to line up for the buffet in the lunch venue. But if you're not so eager to do this, we could continue if there's a desire for more questions. Anyone have additional questions?
Maybe, Mark, can I suggest to comment a little bit on EOSC, because that was one of the...
Oh, sure, yes.
Yeah, I mean, from our perspective, but I would like to know also the opinions of other speakers and just the audience, because, like, of course, we are watching EOSC quite closely, and just now with establishing EOSC Association, we decided to go for observer status, what was granted to us actually yesterday or today, yesterday I believe. So definitely this is something we will watch and learn from that, because I just believe this community should work together and we should learn from each other. So this is our position to EOSC, but we have to see how EOSC and EOSC Association will evolve. Yeah.
Perfect, Martin. Could the other speakers comment on their relationship to EOSC, either as a formal member or in participating in the working groups?
Thanks. You mentioned in the comments, yes, we are working closely with Elixir. They're a strategic partner with GA4GH. And yes, we use EOSC. Yeah, they use EOSC through, yeah, that's our kind of main relationship, I think.
Okay, Peter, Stefan?
Yeah, as you have seen in my presentation, especially the Blue Cloud has quite a close relation to EOSC, and it actually wants to, yeah, create a roadmap to being the blue component of EOSC and play a role in that.
In climate, I think CMCC is now a formal member, so they are representing the climate community. We are also engaged in different EOSC-related projects, EOSC Hub, EOSC Pillar, and so on, to evaluate how the different routes may look like to engage in EOSC.
Brilliant, thank you all. And before people do wander off towards their lunches, I would like to thank all four of you for some really quite informative presentations and an excellent exploration of how to solve quite a common problem, this access to large amounts of distributed data for, in this case, scientific purposes, but it's not unique to science, not unique to the research community. So I think the whole world can learn from the solutions that you are building today. I think if people do want to continue, it should be okay. But if there are questions any additional questions? I have 100, but we don't have time for that.
Can we voice one question? Can I?
Sure.
Yes. Actually, Federated Cloud, something what also related to EOSC and to another project that we are participating. We are looking for common platform for infrastructure provisioning. So one of the issues in EOSC, they are proposing data integration, but each project is rebuilding infrastructure from the scratch. A lot of work for engineers, but there are many things that can be automated if the proper platform for provisioning infrastructure as a service will be deployed. Are any research projects that think about proposing the common I would say, research infrastructure platform as a service. So based on the configuration of data required processing, the whole stack of infrastructure services is provisioned. It's not a standard cloud infrastructure as a service, it's not standard platform as a service. It's rather related to the concept promoted by TMF, Telemanaged Forum for infrastructure as a service. Okay, they propose a platform for provisioning the whole stack of infrastructure services. Is any work currently known?
Hi, it's Tatiana speaking. Can you hear me? I don't find a way to raise my hand. Sorry, I jumped in. So from an EGI perspective, we have this service enabled in the EGI ASA project and in EOSCAB. The big difficulty is that there is not a single ontology for any kind of data set. So solutions that concern infrastructure provisioning based on data locality, for example, depend very much on how this data locality is encoded in the metadata. So there are quite a few technical solutions, but integrating data and infrastructure and doing it in a general purpose manner is not easy. So what we've been doing in EOSCAB is doing these for specific thematic services, where essentially the data discovery is already delivered for specific domain data in the virtual research environment, which is a step forward, but not a complete solution. It's quite a challenging problem, not the infrastructure provisioning per se, but having this integrated with federated data.
Mm-hmm. Stefan or Rishi, you want to talk to this at all?
So I think one of the things we've done that makes it maybe, so the ENA, for instance, is a repository of genomic information, and often when research is done, it specifies that the data needs to be deposited in these locations, and the EBI being one, and the ENA being one. And one of the processes they've worked on has been to unify descriptions of information coming in. So what's your experiment detailing with, what species is it dealing with, what kind of problem are you looking at, which then makes the sort of search and discovery aspects easier to follow up on. So that's something they've put a effort into over the past few years, and then follows on from how do you retrieve that data. For instance, we have our RNA-seq is a particular type of data that is quite common in our space, but high volume. But if you can sort of slice that up according to the problem area of interest, it becomes much smaller. So but getting people to fill in those forms, I think, is the key. Is the key to making it standardized.
Great, Stefan, you want to address this point of configuration, orchestration, etc.? You don't have to.
I have no specific points to add to this, I think. Yeah.
Okay, perfect. So thank you very much, Yuri, for your question. I have one other question right now from Samuel Bernardo.
Good morning, everyone. It's just a comment to Yuri's question. There is a project that is EOSC Synergy. We are looking for the automation of the deployment of several services that includes the requirement for repository demands and for data management with the FAIR principles. Maybe I can give left here some references for those that are interested about that.
Sure, yes, you can put those in the chat. That'd be great.
Yes, please put in the chat. Very interesting.
Okay.
Okay, thank you very much. I want to again thank our 4 presenters. Peter had to leave, but some great discussion. We've learned a lot, and I will let everyone go off to their lunch in their respective time zones, and have a good day. Look forward to seeing you at the next session after lunch at about, I think, 2 p.m. Central Time, Central European Time. Take care.
Thank you.
Thanks, Mark. Thank you.
Bye.
Bye.